Good afternoon, everybody. I hope I'm audible. Audible? Yes. Okay.
Yes, sir, you are.
Good.
Yes, sir, you are audible. Good afternoon.
Good afternoon. Very warm welcome to the CDS Research Admissions 2026. I am Deepak Subramani. I'm an associate professor at the Department of Computational and Data Sciences at the Indian Institute of Science. I've been here for the last 7 years. And today the goal is to introduce you to the research admission process that we will follow in this for the next academic year. So that is the research admissions 2026. We'll wait for a couple more minutes. It's like exactly 6 o'clock now. So I'll just wait for 1 or 2 more minutes and I will start the presentation. So the goal is to ensure that all of you know how the process goes and answer any questions that you may have. So in the Teams, there is a Q&A tab. So if you have your questions, you can type it in the Q&A tab. So it's a little bit easier for me to look through all the questions one by one. You can also use the chat if the Q&A is not visible. But in chat, I just have to scroll through that, right? So it's a little bit more time consuming that way. So you can use the Q&A tab. It will be helpful for me to answer all your questions. So we will try to answer all your questions and I will be here as long as it is needed to answer all your questions. Some of my faculty colleagues might also join in to talk to you all about their labs so that you can make that choice, right? So we are just waiting for a minute before some more people join in, and then I will get started at 6:02 sharp. Right? So, okay, I will start. So once again, a warm welcome to all of you. We are very excited to have you all participate in the CDS Research Admission 2026. And we look forward to hearing from the brightest and best in the country and have you come to our department and do research. First, I will start off by telling you the most important dates that you all must remember. And the very first date is the session now, which I'm conducting on the 28th of April, 6 p.m., where we will discuss all the modalities of the interview process. You all must have received a candidate information form, a Google form with several questions about your background and the lab selection that you must do. I will describe all that process today. The deadline for that is 4 May, that is next week. So please do that after today's session, after learning sufficiently. And the actual interview, the in-person aptitude test and oral interviews, I'll describe all of those things for you in the next 5-10 minutes, is 11th to 15th of May. So these are the most important dates that you must be aware of. So let me start off by telling you about the department, the CDS department. Right? So the CDS, Computational Data Science, is an interdisciplinary engineering department at the Indian Institute of Science. The department was established about 11 years ago in 2015. It is the first department in India that focuses on computation and data science, the most important or advanced area of interdisciplinary research today in India. And remember, 2015 was before the pre-transformer era. So in some sense, our department has been visionary in setting up this whole interdisciplinary exercise even before, the modern large language models became very popular. And broadly, the department contains very vibrant streams, research streams. The first stream is the computational science and engineering stream, which is focusing on numerical methods, scientific machine learning, More and more today, almost all labs do some amount of machine learning in the scientific machine learning sense. Then advanced subjects like quantum computing and traditional subjects like computational fluid dynamics, interdisciplinary subjects like medical imaging, genomics, material science, especially computational material science, high performance computing, and almost all of us also do what is called as AI for science, right? So this is the computational science and engineering stream within the department. This stream contains about 9 labs that are taking students in this cycle. I will describe what those labs are very shortly. And all students that are getting admitted to the department to work in labs belonging to this stream accept students from all backgrounds, right? So it does not matter what your BTech subject is in or your BSc, MSc subject is in. We welcome all of you, right? So it could be physics, it could be mechanical engineering, it could be civil, it could be computer science, it could be artificial intelligence, it could be data science, it could be mathematics. We welcome all of you. That is the computational science and engineering stream. Then there is the computer and data science stream, in which we have the distributed systems, cloud and edge computing, very advanced areas today, middleware, scalable machine learning. So how do you make machine learning work across devices and serve to millions of customers, right? So scalable machine learning. And the hot area today, natural language processing, large language models, computer vision, deep learning, and to make all of this work, the parallel computing, the background that is necessary for modern infrastructure, databases, all of that is covered under the computer and data systems stream. And in this admission cycle, there are 5 labs in this computer and data systems stream that are accepting students. These labs only accept students with the EECS, circuit branch background, right? So you must have a BTech or an undergraduate degree in one of these electrical engineering, electronics communication, IT, data science, AI, those type of fields, right? So you must have a BTech in that. The computational science and engineering stream, we accept students from all backgrounds, and we do wide-ranging work, starting from numerical methods, scientific machine learning, material science, HPC. The computer and data systems, as I said, works on distributed systems, cloud and edge computing. That's basically machine learning systems, scalable machine learning systems, middleware, and then natural language processing, LLMs, computer vision, deep learning, databases, and parallel. Right. So that is about the department. Now, if you were curious about who are the existing students, what like how many faculty do we have, etc., we have about 18 faculty in the department and 60 PhD students as of the last admission. We have 116 MTech students. These are current students, right? So not including people who graduated. Overall, our faculty and the labs, we have published more than 1,500 papers, which have more than 68,000 citations in the full lifetime. We have active industry collaborations with Google DeepMind, Microsoft, IBM, Intel, Shell, Siemens, G Healthcare. We are in Bangalore, right? And all the big companies in Bangalore, they have an association with the Indian Institute of Science and specifically with the faculty in the Computational and Data Sciences department. We also have at least 2 faculty-led startups by the faculty in the department. These are deep tech startups, one in the bioinformatics field and one in the AI for sciences field. And we are a very vibrant industry collaborate. We have very vibrant industry collaborations, and it is only growing. Right? So year by year, it is growing. Our students publish in the top field, top quality venues in the field. If you take AI computer science conferences, we are there at CVPR, ICCV, ECCV, ICML, ICLR, NeurIPS. You take any of the top conferences, we are there. You take any of the high impact journals, right? So Nature Computation, Nature Methods, material science fields, right? So Proceedings of the Royal Society, our students have published in those journals also. And we are very rigorous in the type of work that we do at the department. If you look at the PhD graduates that have recently graduated, they joined the industry like Google DeepMind, Meta, Intel. Many of our alumni also get placement in the United States, right? So these big labs in the US, they work directly there. There are global deep tech startups that our alumni are working in, especially in computational material science, fields like that. ExxonMobil oil and gas industry, you take IT companies, hyperscalers, you take banks, you take trading, you name any of the fields, right? So our alumni are there in those companies, right? So, and these alumni only come back to conduct the interviews and so on and so forth. So there is a lot of industry collaboration through alumni that take place with the faculty, with the students, and there's a lot of mentoring support there. Our PhD graduates also go on to academia. They take a postdoc positions abroad and faculty positions. Several of our alumni are faculty in schools at Europe, India, the United States, right? So there is a wide network of our alumni working in top academic positions across the world. During your PhD, if you are smart, right? So and you know what you are doing. We also offer enhanced fellowships. Many of our labs have industry funding that allow us to top up your stipend, and this is reserved for the top students, right? So if you are really good and you work in our labs, you do get an additional stipend. It could be from PMRF. We have 10 plus students in the PMRF. We have 3 PhD fellows, Google PhD fellows. We have Qualcomm Innovation Fellows, we have Intel PhD Fellows, we have Reliance Foundation Fellows, Axis Bank offers fellowships, TCS offers fellowships, and all these fellowships are very competitive and they pay enhanced fellowship, right? So over and above the amount that you will get from the MHRD, right? So, and this is reserved for the PhD students that are doing top quality work during their PhD. We also have liberal travel support. Most of our faculty have grants that support travel for you to attend all these top A-star conferences, right? So whether the next ICLR is going to be in Western United States, and if you join, you work on a paper, you get it submitted and get it published, you can go there, right? So the travel opportunities are also immense. The Institute also has a lot of support, alumni support, as well as the faculty also have support for you to travel to these top conferences and have your work visible, right? So that is very much possible. Now let me come to the labs that are admitting students. I will briefly, this is just an overview. So after some time, the faculty will also join and they will take you through each lab, right? So specifically one by one. So as I told you, in the computational science and engineering stream, we have 9 labs that are accepting students in this cycle. And in the computer and data system stream, we have 5 labs that are accepting students. So the ATCG lab led by Professor Chirag works on computational genomics. The biomedia lab by Professor Vanati Sundaresan works in the AI in medical imaging field. The biocomputational lab by Professor Devnath Pal works in the biomolecular computation field. By the way, all this information is available. I have already shared the email with you with a brochure where all this information is available, right? So I'm just reading it out here so that, if you missed looking at that email, you can know what is happening over here. So the computational and statistical physics lab has computation, statistics, and physics, as the name goes. The flame lab by Professor Konduri. Aditya works on computational fluid dynamics, scientific machine learning. The matrix lab works on quantum and material HPC. Sorry about that. The medical imaging lab works on medical imaging, as the name goes. The tensor computation lab works on scientific and intelligent computing by Professor Ratikant Behera. And my own lab, the Quest lab, works on scientific machine learning, physical AI, and deep learning. On the computer and data system side, Professor Yogesh Simhan, one of the topmost distributed labs in the country, is the Dream Lab, where you work on hybrid clouds, edge accelerators, federated learning, scalable graph analytics, graph neural networks. I don't think there's any other lab in the entire India which works on that kind of combination of distributed systems computing. Same with Mars Lab, right? So we have parallel and GPU computing, HPC middleware and runtime systems. NLP lab, the natural language processing lab by our young and dashing Professor Danish Pruthi, works on natural language processing, responsible AI, And the department chair is working in Vision and AI lab. Professor Venkatesh Babu works on computer vision, deep learning, one of the top AI researchers in the country with a lot of publications in top venues like CVPR, ICCV, CCV. Same with Professor Anirban, also VCL lab works on visual analytics, machine learning. So this is just an overview of the key topics, right? So that each of this lab works on. I will tell you how you can go about looking through each lab, getting an idea and making your choice very shortly, right? So before I go into the lab specifics, let us look at the interview process itself, right? So what happens on May 11th? There are several questions in the chat and QA about the topics of the interview, etc. Right? How do you get selected? So let's walk through the interview process one by one. So you would have got a call letter. I see that some of you are saying that you did not receive a call letter. So check once again in the portal. If you don't see your name in the portal, write an email to admissions@iic.ac.in and CC me, deepakns@iic.ac.in, and we will take a look at that. So if you did not check your portal or email today or yesterday, there were some updates, like especially if you did your GATE subject in mathematics or civil engineering. So there has been some update in the selection. We did that only yesterday, so there might be some delay. So if you received the email from me only today, that means, right, you got there was some bug in the portal, right? So that made it little bit delayed. So check that once again. In your call letter, you would have been assigned a morning session or an afternoon session on some day between May 11th to May 15th. So if you are in the morning session, please report to the department by 7:45, 8, right? So don't delay, like come by 7:45. And if you are in the afternoon session, we ask you to come at 1 o'clock, but you please come by 12:30 or so, right? So to the department, then get your documents verified. We do expect lot of students to turn up, so you come early, right? So that our process goes smoothly as we want them to be. So after a quick identity verification, so you walk into the department, you will come to one room where your identity will be verified against your government issued ID, your face and the name, right? So that will be verified, and you will be sent to computer stations to attempt the phase 1, which is a computer based aptitude test. I will tell you what the syllabus, questions and all are going to be in the next slide, but this is the phase 1. This is an aptitude test. In this aptitude test, some candidates will be selected. Okay? So based on the score that they make in this aptitude test. If you get selected from this phase 1, you will then move on to the interview panels for face-to-face interviews. This is the phase 2 of the oral interviews. So there is a phase 1, which is a computer-based aptitude test. The phase 2 is an oral face-to-face interview with the labs that you selected. So which panel will interview you depends on the lab preferences that you put in. So it is very important that you fill in the candidate information form that we have shared, the Google form that we have shared. You have to fill in which labs you prefer to go. So some candidates, right, so not all candidates, but a few candidates may be required to attend multiple panels if their chosen labs are spread across panels. So one of you had asked, like, till when should you stay back, right? So if you're in a morning session, you expect to stay until maybe 3 p.m. or so, right? So in the department. It could get delayed, so we would suggest that you book your ticket to go back only the next day, right? So not on the same day. Afternoon session might go on till 9 p.m. or so, right? So 9-10 p.m. it might go on. So please plan to stay, especially if you have selected labs that go across panels. You might have to attend interviews in different panels. So this is not for all, but some it might come. So to be safe, right? So you plan your return only very late at night, right? So after 9 p.m. or so, or the next day, right? So just to be safe. The phase 1 aptitude test, right? So this is, I think, one of the often frequently asked question. So the syllabus for this test is as follows. There will be a part A and a part B. So all of you mechanical engineering, civil engineering, chemical engineering students, please listen, right? So you BSc physics, mathematics students, please listen very carefully. So part A, mathematics questions, there will be 5 such questions for you from the topics of combinatorics, linear algebra, matrix algebra, probability statistics, differential equations, and interpreting the plots. This will be at the level of engineering mathematics 101, year, first year, second year subject, right? So in most of the engineering courses. Some might be at the level of the joint entrance exam, right? So some combinatorics questions might be at the level of the joint entrance exam, for example, right? So like how many ways can you write a 3-letter word from the word Mississippi, right? So those kind of questions, right? So like what are the eigenvalues of a particular matrix? Then Bayes law based probability and statistics questions, right? So mean, median, mode kind of questions. Like what is the plot of y equal to x square, right? So what kind of plot is shown here? Those kind of questions, right, will be the part A mathematics questions. The part B will contain programming questions. So now listen carefully. If you have selected, right, so if your background is in the ECS subjects, right, so you know data structures, algorithms, etc., you attempt those questions. The part B will actually contain 4 questions, right? So 4 questions it will contain, of which you have to answer at least 2 questions, right? So these 4 questions might contain a mix of data structures, algorithms, and programming questions that somebody from a mechanical engineering background can also attempt, right? So don't worry that, oh, I have not done a course in DSA, data structures and algorithm. I don't know what is first in, first out. I don't know how to sort a reverse linked list. If you choose to work in labs that do not require the ECS background, you are not required to answer those questions, right? So you can, in fact, choose 2 questions that you are comfortable with in this part B programming, which has four questions. The total test, part A plus part B, will be around 45 minutes and it will be done on the Hacker Earth platform. You do not have to bring your computer. You just report to the department with your documents, call letter, and all those things. And you can attempt the questions on our computers. So we'll have computers set up in the department for you to answer these questions. So as I said, part A, how many questions? 5 questions. These 5 questions will be from mathematics. All 5 questions are compulsory in part A. In part B, there will be 4 questions in programming. This will require you, some questions in part B will require you to write code in Python, C, C++, or Java to implement your logic, compile and submit to pass those test cases. A basic code template will be given, but there will be no code assistance. There is no VS Code. There is no autocomplete. There is no ChatGPT. There is no Cloud Code. There is no Codex. It's not available. You have to use your logic. You may also be asked to debug a code block or critique a solution devised by an LLM agent-based coding system. So this will be if you choose those questions to answer, right? So we do encourage that, if you want to go to the ECS labs, you should attempt the DSA questions in the part B, but it's up to you, right? So there are 4 questions in the part B. And very important, as a research students, you should know, right? So which problems I should solve. So you should figure out among these 4 in the part B, which problems that you can solve and you are comfortable with. Solve that first before moving on to difficult problems. You can solve all 4 problems also, right, in part B. But we do think that, with a given amount of time, most of you would be able to answer 2 questions. So that's what we think. But if you are super smart, like super brilliant, you answer all 4 get corrected, your chances of course increase, right? So that we leave it open-ended, right? So in some sense. So this is the phase 1 in-person aptitude test. Most important things for you to remember: part A, part B, part A mathematics, part B programming. In programming, attempt the questions that you are comfortable with. There will be questions that would be answerable by students from a mechanical engineering, chemical engineering, civil engineering, physics, mathematics background also in that, right? So, so those students will not be at a disadvantage, right? So you can answer. All right. So that is part the aptitude test. Now, from this aptitude test, some students will be selected, some students will not be selected based on the score that you have. The selected students will move on to the phase 2 in-person oral interview. So in this phase 2, right, so we will announce the result of phase 1 within about 30 minutes or so from concluding the test, right? So we hope that in the morning session, By 10 o'clock, our oral interviews will start. And in the afternoon session, we do hope that by 3 o'clock, the oral interviews will start. It depends on how you cooperate, how you come on time, right? So, and write the exam. So we must keep that schedule. So we do hope to start the oral interviews by 10 o'clock or so in the morning and 3 o'clock in the afternoon. Right. So as I said, only those who qualify, right? So can in the phase one can attempt the afternoon. I mean the in-person oral interview. So what questions will be asked in the oral interview? Right. So in the oral interview will be in a panel where your chosen faculty and lab is present. Right. So that will be the panel that is interviewing you for most cases, unless we have some schedule problems. Then you might be interviewed with some other lab, but mostly, right, so you will be interviewed in a panel that has the top choice that you have, right? So that will be the panel that interviews you. There will be basic questions like linear algebra, probability, some programming, data structures, right? So some logic that you must write on the whiteboard, some discrete mathematics, and you need to prepare at your engineering mathematics level. Take a few subjects in this list you are most comfortable with and prepare that. You can inform the interview panel that this is the subject that you have prepared. Please ask me a question in this subject, and most likely you will be asked a question in that subject if it is from this list. Right? So that you do. Then, based on the labs in the brochure, those faculty would have given you some advanced topic, right? So, and there might be questions in those advanced topic, especially if you have selected the ECS labs, right? There will be advanced topics based on the topics that faculty have listed in the brochure, right? During your oral in-person interview. All right. So that is phase one and phase two of the interview. Now, general advice on how to prepare for interviews. So please prepare the basics. Right? So that is a basic mathematics from that list subject. What do we test for? We actually test for how you think rather than what you know. So the goal is not for you to remember 100,000 things and recollect. For that we have LLMs, right? So they will retrieve information from the internet. We do not require human beings to retrieve information and regurgitate in front of a committee. That is not what we are looking at. We want to test how you think. Are you good at picking up clues and thinking through problems? So then why this topic, right? Why probability, linear algebra, etc.? Basically, that is a medium for us to talk about your thought process, right? So otherwise, how do we communicate? Right. So if I ask you a problem in probability, I want to see how you break down that problem and think through the process. Are you looking at edge cases? Are you looking at the data that is required to answer this question? If you are looking at a data structures problem, right? So are you looking at it from the viewpoint of how a graph has to be traversed, how a tree has to be traversed? Are you applying the concepts that you learned in a programming 101 to the problem at hand? For example, right, so we might ask you a question. The Ganga River is flowing at 10 meter per second speed. You are on one ghat and you want to go to the other ghat. So at what angle should you drive the boat? This is a general mathematics, general physics awareness question. So here we want you to think through vector calculus, combinatorics problems, right? So vector calculus and matrix calculus per se, not combinatorics, sorry. And think through how those vectors should be, and then draw that diagram. We are interested to know how you respond to questions under pressure and something that is thrown at you randomly, right? So from out of nowhere. And if you are able to hold tight and answer that logically, think through steps, your chances will be very high. And this is what we expect the students to research students to know, right? So please do prepare in that direction. Okay. So now we have faculty who have joined. It's about 6:30. So I will open the link, right? So that is a research degree, the CDS website. As I told you, there are about 14 labs that are accepting students. Once we hear from the faculty about each of their labs, right? So we will then proceed to how you should make that selection, right? So this is the brochure that I have shared with all of you already. which discusses exactly what I told you in the last 30 minutes. Right? So I made the presentation from this brochure, of course. And if you go down, right, so all the information that I have told you is present in this brochure. Information of the phase one, phase two, online information form, that Google form that I've shared with you, right? So all of that information is present. The topics, what you have to answer, what is there in part A, what is there in part B, all of this is present here. It's a fairly detailed document, so please go through this document very carefully. And then you have the list of labs with information. So what I want all of you to do is there are totally 14 labs in the department. And for each lab, there's a short lab description, interview topics, and prior training that the lab faculty expects you to have. So please read this, go to the website that is listed, spend about 30 minutes per lab, all labs, right? So spend about 30 minutes reading about what that lab does and evaluate that against your own interests. So what you are interested in, will you be happy working on those topics? So I'll give you a talisman, right? So that is one question that you must answer. And if the answer to that question is yes, you must select that lab. And that question is, imagine the worst possible day in your life. So imagine maybe your girlfriend, boyfriend broke up with you, right? So you fell off your bike, you lost $100,000 in crypto, maybe RCB lost a cricket match, right? So the worst possible day you imagine, right? So next day, will you be okay to wake up and go to the lab and work on those topics? If the answer is yes, select that lab. You have found your ultimate goal in life, right? So you have reached the pinnacle of happiness. You select that and you come, right? So that would be one way in which you can then decide, right? So that is which is the lab that I want to try to go. But to answer that question, you must spend at least 30 minutes reading through the lab description, interview topics, website, go through some of the papers that the lab would have told you in this document, make a list of the things that you liked there, that you disliked there, and you yourself think. Please don't outsource this thinking to a GPT machine. So about 40 of you have already answered the candidate information form, and I think about 35, 36 of that is direct, very simple prompts, right? So, and you have pasted it back. You can do that, right? So of course, but you are reducing your chances, right? So you please spend the effort to understand is what is going on over here, and then go about, right? So let me see if Professor Chirag is here. If yes, I don't think Professor Chirag is here yet. So Professor Chirag works on, so I will just quickly go through. Professor Chirag works on the ATCG lab, which is at the intersection of computer science and biology with the goal of accelerating discovery in the life sciences. They work a lot on DNA and RNA sequencing. They look for algorithm design and analysis, data structures, basic graph algorithms. And any background in engineering, computer science, or applied mathematics is welcome. Strong programming abilities necessary to work in the algorithmic techniques for computational genomics ATCG lab. Right. So please do go through the website, go through all the work that the faculty have done, and you choose. Is Professor Vanati here? Yes, Professor Vanati is here. So Vanati, you
Yes.
can go ahead and describe your lab.
Yeah. Thanks, Professor Deepak. Let me just quickly share my screen. Um, so can you confirm if my screen is visible?
Yes, ma'am.
Yeah. Okay.
Yes,
Great.
ma'am. So
So
Vanati, just take 2 minutes and describe
yeah,
it.
yeah,
Yeah,
I
yeah,
understand.
yeah,
Yes. Yeah.
yeah, yeah.
So this is my lab, so biomedical image analysis lab. So we develop automated open source tools for medical image computing. So we have essentially the main goal of our lab is for precision diagnosis. But we have two legs, main legs in our lab, the main aims, I would say. First one is the detection of biomedical biomarkers, medical imaging biomarkers which are related to various diseases. The second things are overcoming practical limitations of AI, right? So before going into that, I would just I wouldn't go into much detail on this radiological workflow. What I want you to understand is there are several steps involved, starting from acquisition, processing, and also cleaning up the images. But what we work on is this part of the overall pipeline, which is image-based tasks. Once the images we acquire from the machines are being pre-processed and it's ready for analysis, we do our analysis on the images for detection of biomarkers. This is what I was talking about, and characterization, like segmenting the lesions or any abnormalities, looking at their quantitative metrics, the diagnosis, and staging the disease based on them, and also monitoring longitudinal analysis as well, which could be later on used for reporting or some integrated diagnostics if things work well, can be used in the clinical practice. So what we work on, as I told you, extraction of imaging biomarkers. So here I have showed for neurological disorders, but we work on various other modalities and organs as well. And the second aspect is the privacy protection or also domain adaptation, which is adapting a deep learning model which is trained for a very specific task on a specific data set to multiple centers. Imagine getting data from multiple centers, right? You train the model on only one center. How can you make it work reliably on multiple centers and from multiple sources, overcoming a lot of issues here, right? So missing data, data inconsistencies, and so on. So here, when I talk about biomarker extraction, there could be data limitations, label limitations. It's particularly predominant in medical imaging because the data we acquire might not be large data all the times, right? So how can we overcome multiple modalities and the lack of manual annotation? So self-supervised methods, weak labels also. Sometimes labels are available but not of good quality, right? And explainability, very important in medical imaging, like overcoming domain shifts to understand what is domain shift and to explain it explicitly for clinicians, and inconsistencies in manual annotations and in yes or no problems, classification problems, understanding what causes, how the model makes that yes or no decision, right? And finally, most important slide, right? So what enables this research? What can we offer for you, our lab? So high memory GPU servers we have, and we also have access to large scale medical imaging data sets. In the process of procuring another one now, so you will definitely not have a data set shortage problem. And that's also partly due to the collaborations we have with clinicians and within India and international researchers as well. What do you get out of the lab? Right, so during the time you spend in our lab, so you get to publish in top venues. I have listed only conferences, but you also get to publish in top journals. We always do not compromise quality, so we publish in good venues, and work on open research problems, and also independence, which is very important in research scenario, right? And which enables you to become an independent researcher with my mentorship, and also you get to interact with like-minded students, right? So looking for strong MLCV background. So I have mentioned that ECS and also relevant backgrounds, but please do apply if you are from other backgrounds as well, if you are interested. If you have the relevant skill set, you will be definitely considered. So please don't make that as a restriction for you. And research mindset. If you are interested in research, solving open problems, and also looking at a problem from different aspects and aiming to solve the problem, right? So that is definitely a plus. Interest in healthcare impact. I completely agree with Professor Deepak here. You should not compromise anything for your interest in a particular subject, right? Only choose the project or the particular lab if you are interested in it. If you are interested in healthcare, definitely choose our lab, right? And yeah, so looking forward to meet most of you during interview process. All the best, and do your best while selecting the labs. Thank you very much.
Thank you, Professor Vanati. So once again, Professor Vanati is the head of the biomedia lab. It's a biomedical image analysis lab. So next we have Professor Devnath Pal's lab, biomolecular computation laboratory. So this lab works on understanding biological data for insights into biological structures, functions, and processes at multiple scales. Students are expected to have programming knowledge and sound understanding in one of the subjects like math, physics, or chemistry. Data science, bioinformatics, computational biology. If you have some exposure, it is good. But any background and knowledge and enthusiasm for learning biology and doing computation in that is very welcome in this lab, the BCL lab. So you please look through the website, look through the graduated students, look through the papers, right? So and then make your choice. As I said, I'll spend at least 30 minutes per lab, right, when you are going through and making that. Then we have the Computation, Statistics and Physics Lab, the CSPL lab, Professor Murugesan. I don't think Professor Muru is joined here. So I will just describe what that lab does. So the CSPL lab works on theoretical and computational models in condensed matter physics. They do work on randomized algorithms and statistical computing, numerical methods and scientific computing. They are actually looking for PhD students to work in the theoretical and computational models in condensed matter physics. That is what their primary interest this time is. But if you are interested in the other areas, right, so you can indeed select the CSPL lab. Do go through the lab description, go through the recent papers, publications, and what the lab's research direction is. Right, so spend some time, read through that, and then see what you like, see what you dislike, and then make your choice. We have Professor Konduri Aditya's lab, Flame Lab. Is Aditya online? No, I think he's not yet joined. But if he joins, I will let him speak. But the Flame Lab works on simulation and analysis of multi-scale, multi-physics fluid flow problems that leverage HPC and machine learning. So today, right, so most of the labs that I'm going to talk about, like the Flame Lab, the Matrix Lab, my own Quest Lab, the Tensor Computation Lab, we are all what is called as a multilingual lab, right? In the sense that we have a core area like CFD or flow analysis, material physics, or some fluid dynamics related aspect. We speak the language of that domain. We speak the language of the computation, the HPC, and we speak the language of AI and machine learning, the scientific machine learning. So today, to be successful, right, so you have to be multifaceted, interdisciplinary. So Flame Lab is one example where you combine aspects of simulation sciences, HPC, parallel computing, new methods, numerical schemes, asynchronous computing, so on and so forth. The pinnacle in HPC and the state of the art in scientific machine learning, combining solving PD, CFD, uncertainty, all in systems such as combustion systems like gas turbines, scramjets, high speed aerodynamics, environmental flows. So that broad taste, right? So you will get in all of these labs, right? So the Flame Lab, as well as the Matrix Lab, and in my own Quest Lab, the um, Tensor Computing Lab, all of these. So interview topics would be numerical methods, linear algebra, probability, scientific programming. This is in addition to the basics, right? So that is the matrix algebra, probability, etc. And this lab does accept students from all backgrounds, something like mechanical engineering, aerospace, chemical, computer science, computational engineering, computational physics, applied mathematics, and we do prefer PhD students, right? So over MTech research. The Matrix Lab, I can see Professor Funny here. So Funny, do you want to give a 2-minute introduction to your lab?
Yes, I don't have any slides, but I'll just speak out, just like you're speaking. Welcome all for this orientation. So if you're excited by the idea of developing cutting-edge mathematical techniques and computational algorithms that can harness the world's fastest supercomputers and quantum computers, you're in the right place, okay? If you're dreaming of working on a highly interdisciplinary research, which can actually push the limits of today's predictive capabilities in quantum modeling of materials, then you're in the right place, okay, through HPC and AI specifically. And if you also want to power your research so that you can actually open up leeway to a lot of open source, exascale ready scientific software, which can place India on the global quantum HPC stage, you are at the right place. Okay. So we actually thrive at the crossroads of various interdisciplinary topics. As Professor Deepak was mentioning, though we speak the language of materials physics, but we work at the crossroads of quantum mechanics, of course, material science, numerical methods, numerical linear algebra, quantum computing, and large-scale HPC, and AI for science, right? So in particular, we focus on developing advanced computational methods, scalable hardware-aware algorithms, machine learning frameworks, and exascale ready codes to accelerate quantum simulations of materials and the drive the next generation scientific discovery where you cannot even attempt to solve some of the problems in materials discovery without these methods and tools we're developing. And as a part of your work, you will also get a chance to dabble with some of the world's fastest supercomputers, exascale supercomputers, where you'll get access sitting right in India. Okay. And we also be working with a Gordon Bell Prize winning code, which has been driving our research. The computational methods which you actually develop will not be just applied on some toy problems. You will actually really see deployed in scale in solving real material science problems. Okay. So recently, we also had dabbling into quantum computing based algorithms for solving eigenvalue problems, again, to accelerate scientific computations and PDEs actually arising in various disciplines. But because we are in materials discovery, and this materials discovery is completely through solving eigenvalue problems, our first use case for a quantum computer is to develop algorithms to accelerate eigensolvers in a quantum computer. So it's not completely quantum-based algorithms. It will be hybrid quantum classical methods. That's where quantum HPC is the right word to describe. You kind of try to find out which pieces of your method can be accelerated by a quantum computer and which pieces of the method is by a classical HPC-based supercomputer. Since our lab actually have made rapid advances in developing these classical based computational methods and algorithms to accelerate on a classical computer, now it's time for us to think if we can power the quantum computers to accelerate many of these aspects and algorithms. So the interview topics for our lab, first of all, we don't have any restriction on which kind of background you would actually have to choose. I would choose from any kind of background as long as you have the right passion to learn and the raw power. We see raw power, the right questions you're asking in solving the problems asked in the interview. Okay, so we are only looking for that. And of course, we would, at least my lab, when we are doing this interview, we would be focusing specifically on linear algebra, calculus, and of course, programming logic. The emphasis of interview topics would be heavily on this beyond what you actually prepare for your written test. And we accept, as I said, any background in engineering. Specifically, we have so far been successful in finding a right interdisciplinary mindset in people who are at the core engineering disciplines and sciences, not really computer science, but we are open to all kinds of branches. Okay. So wish you all the best for your interview and looking forward to see you in the day of May 10th week, right? Maybe the week of May 10th.
May 11th.
Thank you.
Thank you, Funny. And Funny didn't mention, but their lab recently got funding for the quantum computing mission, one of the critical projects of India to make India self-reliant in this area of quantum computing. They are one of the leaders in this field of quantum computing. So if that is something that you are passionate about, please do come. In fact, Professor Aditya, Professor Fani, and mine, one of our dreams is to win the Gordon Bell Prize fully with a team from India. And if some of you are really, enthused by that, right? So then please do come, attend our interviews, join our department, and then we can create history, right? So by being one of the first all India team to win all Indian team, right? So to win the Gordon Bell Prize, one of the biggest supercomputing prizes. Another thing, right? So to kind of motivate you, so Flame Lab, Matrix Lab, and my own lab, right? So we do work on a lot of parallel computing, GPU computing, working on the GPU using CUDA kernels and so on and so forth. If you see the deep learning explosion, right? So why modern AI is so powerful, deep learning, they all came because it started with AlexNet, right? So in the 2012, and Alex was a grad student at that time. He was actually an HPC person, right? So he coded the convolutional neural networks on CUDA kernels. Right? So that knowledge of coding it on CUDA kernels and developing that high performance computing system is actually very, very valuable, and very few people have that, right? So if you do specialize in that, you will reach places, right? So there is absolutely no doubt in that. So that is a matrix lab. So let me move on to the next. I think Professor Fanindra is also not here. So Professor Fanindra leads the medical imaging group. You listened from Professor Vanati on AI in medical science. So Professor Fanindra's lab also works in a similar area, but slightly different flavor, right? So they look at AI powered medical imaging. In fact, Professor Fanindra is now with the Center of Excellence for AI in medicine, right? So that is the TANU, which is at IISc, and that lab is accepting PhD and MTech research students. So please look at the website of Professor Yalavati Fanindra and see if those kind of topics are what you are interested in. Then we have Professor Ratikanta is online. So let me request Professor Ratikanta to introduce his lab in 2 minutes. Professor Ratikanta.
So I'm Ratikant here. So I don't have a slide to present you. So please go to my webpage, or I can share with you my webpage. So
they're already seeing your webpage, Ratikanta. You can just
okay,
talk about it,
okay.
right? So, yeah.
Okay. So my lab is basically working scientific computing and machine learning, and specifically intelligent computing. What you say that AI and what you call the neural network, quantum computing, AI-based quantum computing. That also we are working numerical linear algebra, and then also a scientific, or you can say wavelet in scientific computing, numerical linear algebra, tensor computations, all these things. All these things I put it everything in like slide wise, all this in my web page. Please go through this and have a look. Okay, thank you.
Yeah, thank you. So Professor Ratikanta's lab, the Numerical Algorithms and Tensor Learning Laboratory, you please go through the website as Professor mentioned. The training in mathematics, linear algebra is required, and one of the topics in linear algebra, matrix theory, numerical. By now you get a sense, right? So this group of computational science and engineering labs, we all look at topics in linear algebra, matrix theory, probability, numerical methods. So your interview will be around this area. So you can prepare in one or two of these topics and inform us during your interview, and then we will be happy to ask you questions in that. So the ninth lab in the first section, that is computational science and engineering labs, is my lab, the Quest lab. So we do interdisciplinary research in scientific machine learning and AI for science and engineering. So we balance method development, practical applications. For this year, we are specifically interested in multimodal AI and foundational models for scientific data. So if that is something that is of interest to you, right? So working with large amounts of data, working with lots of GPUs and developing a foundational model for scientific data. Physical intelligence, that is robotics, AI for robotics, working with egocentric video data, and training a robot to, let's say, fold clothes. Our ultimate aim is to, let's say, replace a cook or a maid for household duties, or a CNC machine expert, right? So working in an industry facility, or somebody cutting meat in a butcher shop, right? So we want to replace that with a robot. And how can we do that using intelligence? So intelligence layer on physical systems, right? So that is what we are looking for in the next batch of admissions, right? So if some of these interest you, please do apply to our lab. And in the interview topics, we will be talking about applied probability, linear algebra, and general aptitude, right? So like, how do you think? Then if you know some deep learning and algorithmic thinking, some of the basics of deep learning we will look at. All backgrounds are absolutely welcome. We strongly encourage, if you have a bachelor's degree in mechanical aerospace, civil, ECE, with some self-taught programming skills like deep learning skills. So I myself Actually, all three of us, Aditya, Afani, and me, we all have background in mechanical engineering. Like our BTech is in mechanical engineering, but we do work on computational sciences, scientific machine learning, and as I told you, we speak the multilingual language, right? So we speak multiple languages, and we bring all of that together. Okay, so these are the 9 labs. So once again, they are the ATCG lab, the BCL lab, Biomedia lab, BCL lab, CSPL, Flame lab, Matrix lab, medical imaging, Tensor lab, NATL lab, and Quest lab, right? So these are the 9 labs in the computational science and engineering domain. Now let us quickly move on to the computer and data systems stream. So there are 5 labs there: Dream, Mars, the NLP lab, VAL lab, and the VCL lab. So these labs accept students only from the CS, ECE circuits background. So first is the Dream lab. I don't know if Professor Yogesh, can you quickly in 2 minutes introduce your lab, Yogesh? They are looking at the brochure.
Sure, absolutely. Perfect timing. So thanks a lot, Deepak, first of all, for setting out the lay of the land for the students. Really appreciate that. So our lab broadly works on distributed systems, looking at how can you scale problems, and how can you scale algorithms, and how can you scale platforms to make use of distributed hardware, everything from cloud computing to distributed accelerators to edge accelerators, running from anywhere from a few dozens to a few hundreds of cloud and containers. So we primarily work at the interface between the hardware and the application. So what are the software middleware runtimes, and also the algorithms, distributed algorithms that help make this happen, right? So some of the specific topics we are looking for this year, as you can see listed over there, are there's one theme that we have running for the last year around agentic runtime platforms, right? So in terms of how can you take agent-based systems and have them scale onto edge, scale onto cloud, and here maybe there's even some linkages with what Deepak's trying to do in terms of how can you use agentic platforms for physical AI, embodied AI, for controlling drones and robots and so on, but using automated, let's say, control and navigation from various agents. We also have a rich set of work going on around federated learning. How do you do distributed and federated learning on top of edge accelerators, everything from smartphones to different data centers. We also have work going on around quantum plus cloud, right? So quantum, it turns out, is just another form of accelerator. So even if you've done nothing around quantum physics, you can still sort of pick that up if you look at it more from the classical side of things. All quantum applications actually need a big bunch of classical over there. So we have a National Quantum Mission project, right, that looks at scaling HPC plus quantum. So that's a key project. And we also have a very active work around graph-based, scalable graph mining and scalable GNN processing, which we actively collaborate with NPCI around UPI fraud modeling and so on, using graph-based systems. We do have a lot of collaborations with IBM Research, with NPCI, with Microsoft, and so on. So there's a lot of applied systems research that takes place. And some of the topics that you'd have to be prepared for, have aptitude for, if you are interested in our lab, is around broadly around systems, right? It could be sort of operating systems, networking, could be around distributed systems or distributed algorithms as well. So if you're interested in this lab, do prepare for topics around operating systems at the undergraduate level. If you have taken a distributed systems course, you can always opt for that as well as a possible choice. Or we have a couple of papers also around agentic systems as well as graph algorithms that if you're prepared for, you're welcome to attempt sort of applying to our lab, right? So we are a very enthusiastic and very productive lab, and we're always looking forward to students who are passionate about these problems. Thanks a lot.
Yeah, thank you, Professor Yogesh. As I told you, right, like Professor Yogesh lab is one of the unique labs in India that works on this system side, looking at distributed computing and the data at the level of NPCI, right? So that is immense data. They work on data for public good. So please do look through the website, look through the papers, and do consider joining that if systems is of your interest, right? So next we will move on to the Mars lab. Professor Satish Vadyar, I don't know if he's online. So if he's not online, is Professor Satish online? No, I think. So again, go through the website of the Mars lab, the middleware and runtime systems lab. So Professor Satish runs a lab that focuses on high performance computing, parallel computing, specifically the middleware, system software, algorithms, and application on large scale parallel computers, GPUs. Recently, they have worked on harnessing the power of both CPUs, GPUs in a hybrid manner, specifically for AI ML workloads. Then novel models for parallelism in ML, DL application, machine learning, deep learning. So this middleware, right? So it sits. So you could be an AI developer looking at getting models to work, and then these models have to train on the computer, right? Like for the models to train on the computer, they must interact with that layer which distributes this computing workload across these multiple CPUs and GPUs, and that lab focuses on those kind of systems side of things, right? So fault tolerant framework for parallel scientific and MLDL application. So for them, application is like agnostic, and then they look at the system side. So operating systems, including pthreads files. These would be the interview topics: computer architecture, multi-core CPUs, modern GPUs, and then MPI parallel programming interface. So if you are interested in this kind of work and you have the necessary aptitude and ambition, right? So please do consider that lab. Next, we have the NLP lab. Is Professor Danish online? Okay, if not, so Professor Danish works on natural language processing in the broad area of NLP and AI. So today, large language models, natural language processing is one of the top most topics of interest for students and graduates alike in the industry. So Professor Danish runs one of the topmost NLP labs in the country and at CDS. So he works on detecting AI generated content, broadly working on curbing unhealthy reliance on AI, looking at how evals operate, right? So measuring and improving geocultural representation in AI. So their lab recently won the best paper award at one of the ACL conferences, which is one of the topmost venues for natural language processing research that goes on. Then they work on evaluating large language models, and they want the lab to be very diverse, transparent, friendly. So now the interview topics would be on language modeling, probability and basics of machine learning and deep learning, loss functions, what does a neuron do, what is a nonlinear activation function, right? So what is gradient descent, your model is stuck training, how do you proceed, like those kind of questions. But you must have a bachelor or master's degree in computer science, IT, ECS subjects, right? So that is necessary for that lab. Next, we have the Vision and AI Lab from Professor Venkatesh Babu. So I think he's online. So Professor Babu, can you take 2 minutes and introduce your lab?
Yes, Deepak, shall I share the presentation? Possibly.
Yeah, you can, but just take 2 minutes.
Yeah, maybe, yeah, I should be fast. Yeah,
Yes.
but I know. So maybe, yeah, quickly I will go through this slide. Yeah. Yeah, thanks guys for staying late in the evening. I'll just take 2-3 minutes and then tell what we are doing in this lab. So basically, these are the topics in which we are working. The bold ones are currently what we are working on, fairness and bias, and diffusion models, and exploring the latent space of diffusion models, and also 3D vision using especially Gaussian splatting. We also look at adversarial robustness and multimodal VLMs. Right? So we also worked on several other topics earlier to this, long tail learning, domain adaptation, HDR imaging, crowd analysis, all those things. So maybe I'll just give a glimpse of few of the works. So in source-free domain adaptation, this is basically, especially in the current situation, people don't want to share the data across vendor to a client because of various issues, privacy and proprietary nature, all those things. In this kind of a setup, how a vendor can help the client to kind of build a model in such a way the model can be easily adapted by the client. So it's in a cooperative situation, but the major constraint is you cannot share the data across between two entities. Yeah. So there are several works that we proposed along this line. They were published in many top vision as well as the ML conferences you can see here. So this is one of the major topics that we worked. And also we worked on adversarial robustness, where It sounds so funny. The model that we trained with so many GPUs for so many months, you had a very mild perturbation. The model goes ever. You can't recognize what is given as an input. You can see the first image is same, looks similar to the last image for us, but still the model fails very miserably. So this is one of the major problems with our deep models. And unfortunately, even after 10 years of intense research, we are nowhere near fixing this problem. So it has a huge future potential for research. And yeah, same way you can uh, wear a printed spectacle and then kind of get access to very sensitive locations or access to any other laptops kind of things as well, right? So this is another area where we worked for several years and published many papers. And bias is another major problem that we are facing today because most of the generative models, they were all trained on the data that are coming out of the internet. So you go crawl the internet, text data as well as um, image data. And when you look at this, the model that is trained based on this pooled data, they have huge amount of bias because the data is coming from very few countries, regions, right? So it does not represent other regions well. Okay. So in this kind of a situation, how to kind of, we cannot let go of the data because the data is precious. Wherever you get what data, you have to use it for training. But at the same time, you want to make your model also kind of a fair model. So how to intervene and then create a fair and model is another important line of research that you're looking at. Also, the another area of research is latent space manipulation of generative AI. So you can look at, you try to find a direction for various attributes, and then you can sequentially edit any image and then change the attributes of the particular person without changing the identity. So I will skip this. Then also, yeah, continuing this to the diffusion models, you can also do a lot of things. You can create, given one single image of a person, you can create images like this by just giving a text prompt. Also, you can also do fine-grained attribute addition, basically changing the smile or age, all those things we can do as well. So like this, you can create very nice deepfakes. Of course, they are all deepfakes. You can create such an image and then make it very realistically looking images you can create. So this is one of the works that we will be presenting at CVPR this year, where we have this kind of boxes for each of the objects. They're highly overlapping, intertwined, and then still you can create some scenes, complex scenes like this using this. And once you create this kind of images, then you can also make them come alive, and then you can just create a video. In future is going to be something like this, where going to create the videos from the laboratory, making your movies from the laboratory. So you need not go out and shoot anything. So you can create very realistic, nice videos. You can see the videos are very natural and then kind of even the movement, I should check whether they're exactly the correct movements for the car. So you can create this kind of videos. And yeah, it's a lot of fun to work in images and videos. These are some of the past students and current students. So this is my lab. Please visit our webpage and talk to the students if you want more information. Thanks a lot. Thank you.
Yeah, thanks, Professor Venkatesh Babu. So, even though Professor did not mention, Professor Venkatesh Babu is one of the leading AI researchers in the country with top publications in all the top venues, right? So, as he mentioned, CVPR is also the fellow of the Indian National Academy of Engineering and is currently chair of the department. So, one of the top voices in AI in India right now, right? So is Professor Babu leading the Vision and AI lab. So if that is something of interest to you, you have the aptitude, please select that lab. Next, we have Professor Anirban Chakrabarti, who also works in the computer vision space. So Professor Anirban, if you can quickly introduce your lab in 2 minutes, that would be great. I can share the blurb if you want, or are you going to share your screen? Yeah, that's good. Yeah, you can start talking. I will share.
Hello. Yeah. Sorry, I'm traveling, so my it would be a bit noisy. So please excuse that. So as Professor Deepak has mentioned, so my lab works in computer vision and application of machine learning in computer vision, distributed computing, and optimization, and many other areas. So thematically, we are very interested currently in three areas. So one is multimodal AI. So where we try to combine computer vision, text analysis, and additional uh, tail modalities, which are not very much predominant in the training data of modern multimodal LLMs. And we try to make sure that, the LLMs are, capable of taking into consideration all these modalities when they make their final, any particular task specific inference. So we have recently published our work in AAAI on sketch understanding in the context by multimodal LLMs in the context of several tasks like VQA, counting, detection, and so on and so forth. The other area that we are interested about is generative modeling. And even in this area, we are interested to build generative models that enable us to maybe edit audios of a video, right? So suppose you have a video and with a prompt or with any diffusion model or any text to video diffusion models, you change for that particular video. Now the audio track that should also change accordingly, right? So this is one problem that we are currently looking into. So instead of generating audio tracks with a video to audio model, you should have some sort of a correlation with the audio track that the original video had, and then change it accordingly. We are also very interested about the evaluation of video generation models. So one of our recent work, which we have submitted to CCV, looks into evaluating how good T2I text to image generation model is in terms of reliably producing crisp human-like images. So that's one area, and we want to extend that to videos as well. And the other area that we are extremely interested about is federated and distributed learning, so privacy preserving distributed learning. And we also work on theory of generalization, distributed min-max optimization, and many other problems. So yeah, I would leave at that. So if you're interested in our lab, please get in touch with the students, look at the lab's webpage, and prepare well in probability, linear algebra, and basic machine learning topics. Yeah, that's all from my side. Best of luck.
Thank you, Professor Anirban. So I know it is a lot to unpack, right? Like 14 labs in 40 minutes. So we do understand your pain, right? So as maybe 23, 24-year-olds, coming and looking at this amazing lineup of cutting edge research spanning from high performance computing all the way to AI, NLP, it's hard for you to, grasp everything. So what do you have to do, right? So you have the remaining 3-4 days. We just went through all the 14 labs that are accepting students. You know where to get the information from. So now you have to do some homework. You have to wear your researcher hat, right? So and answer some questions to help you, realize which of these 14 labs is your home, right? So and you must do that, right? So you must not be like, oh, somebody else told me that this is the topic that I must work on. Like that may not be the appropriate way to do it. So how would you decide, right? So which is these labs that you want to do? So as I told you, please spend about 30 minutes per lab, right? So go through each website, read the description and the background that each lab is looking for, look at the topics, right? So, and then shortlist a few, right? So maybe from the 14, shortlist some 6. So in the 30 minutes per lab that you spend. Then you spend another 3 hours looking through the papers, looking through the faculty's website, right? So, and then writing down all things that you like, things that you dislike, or things that you don't yet understand, right? So go through that and then spend, like, maybe select three from that, right? So from this, and then spend about 10 hours per that 3 lab, right? So, and then look through their recent papers, publications, and then decide, okay, this is the order of labs that I want to be in. Okay. While doing this reading, you must answer the question, will you actually enjoy studying the subjects to succeed in the research conducted in this lab? See, there's a big mismatch between your ambition and your aptitude, right? So ambition must meet aptitude, and that is where the mismatches happen, right? So that is, a rubber hits the road, right? So, as they say. So you must match that, and you must answer, why are you choosing this lab, right? So is it because someone else recommended it? You have no idea, but like somebody said that no, this is the field that is you must work on. So all that is today's knowledge, right? You are looking at 3 years from now, like 2-3 years from now, what would be the situation, right? So is it because you genuinely enjoy the work and have aptitude for it? If yes, absolutely select that lab, right? So is it because it has the highest chance of admission? There are several questions that are coming in the chat. How many seats are there in the department? How many students are being admitted? Like, what will you do with that information? Please do not try to select a lab or group based on your perception of the probability of getting selected. You study probability, okay? We'll ask you questions in probability, but you do not have enough data. Actually, we also don't have enough data to tell you, right, what is the probability of success if you select one particular lab or not, right? So it depends entirely on your merit and what you do on the day that you come to the interview, right? And as I told you already, and this I think is one of the most powerful talisman. You can apply it anywhere in your life, right? Not just in this selection. Imagine the worst possible day in your life. As I told you, this might be the day that RCB lost. Might be the day that your girlfriend or boyfriend dumped you. It might be the day that crypto that you had, you missed the password for it. Worst possible day, right? So imagine that day. Next day, will you still be motivated to get up, come to the lab, and engage in the work? If the answer is a resounding yes, please, that you are the right candidate for research. Please do select that lab, right? So, and please do come. So while going through each lab, you write your likes and dislikes, right? Go through the faculty page, go through the profile of other students, see recent papers, see where those students end up in, right? This is the process of research, right? So if you enjoy the process of researching the lab of your interest, right? So that is your research day-to-day life will be very similar. If you do not enjoy this process, maybe research career is not the right option for you, right? So please do that, and ultimately choose labs that you are genuinely interested in. All labs are top class, right? So it's not like one is better than the other or anything like that. All labs are good. All faculty are doing cutting edge research, right? So, and please do make a decision that is your own, where you will be happy to spend the next 2.5-3 years, right, so of your life, and come out successful. We all faculty here want all of you to succeed, right? So, and whatever way we can help you in achieving that success, we will do, right? So we'll go to the end of the world to ensure that you are successful in the chosen career that you have. And so this process, this webinar, right, so this information session is designed to help you make that choice, right? So now, another pressing question that many of you have in your mind is like, what are the career opportunities after PhD, right? So there are several opportunities after PhD. One, of course, is academia in India, the public institutions and private institutions where you do teaching and research. Like all of us are in the Indian Institute of Science, which is a public institution. So you require a PhD to be here. If you see many of the IITs, the faculty teaching at IITs would have got their PhD from IISc, right? So you see the value of a PhD from IISc. It's immense. National labs and operational agencies like Ministry of Earth Sciences, ISRO, BARC, all these national labs and operations, they do have scientist positions with where the PhD will really help you go ahead in career. Industry in India, we are in Bangalore, right? Bangalore is the hub of computational AI labs, physical AI labs. In fact, Skilled is opening a new office in Bangalore. Amazon is opening a new office, like right north of our campus, right? So it's like hardly 20 minutes or something from our campus. And they are all hiring like crazy in research, development, operation, business role, high paying roles, multifaceted roles in startups, global startups that have their presence in India. Our alumni are in all these places, right? So many AI companies actually hire globally, and our CDS alumni are working in, let's say, Meta, Fair, MSL, right? So it's top of the game, right? So we are here. Okay, so next, let me quickly look at the questions, right? So that are coming through. So let me keep this slide here and then take the questions. So first I'm going through the Q&A questions that you have posted. I will read each question and answer. Okay. I'm still confused. Is MTech research and PhD we are talking about same? Excellent question. I had a slide on PhD versus MTech research, and I was going to tell you like what the difference between PhD and MTech research is. So, see, MTech research is a master's degree. PhD is a doctoral degree. See, there are also some questions about what is the difference between CDS, AI, CSA, all these questions, right? So some questions were there. So IAC, believe it or not, IAC actually the final degree that you get from a PhD will just say Doctor of Philosophy. That's it in engineering. It will not say which department you graduated from, right? So it will just say Doctor of Philosophy in engineering or Master of Technology bracket research in engineering. That's all it will say. It is only in the transcript that you will have the courses that you took, the department that you did, or the topic of your thesis, etc. will only be in the transcript. The actual degree certificate will not show which department you did your PhD or your MTech research in, right? So, in fact, right, so the life of a PhD student is heavily dependent on the lab that they do their work in. The department is only an administrative unit, right? So where you have to get permissions for taking leave or for permission for conducting your comprehensive exam. Those things the department will handle, but your day-to-day life depends on the lab that you are working in. So you can end up in the same lab through a PhD in CDS or a PhD in AI or a PhD in IMI or a PhD in climate change or a PhD in energy. It's a many different routes if that faculty is associated with that route, right? So you can definitely enter there and do your work. So the question about what is the difference between CDS and AI is just administrative unit is different, right? So the lab that you do your research in is what ultimately matters. Now, what is the difference between MTech research and PhD? Typically, right, so in the fields like AI, scientific machine learning, HPC systems, the amount of work that is required to get a MTech research or a PhD are virtually equal, right? But a PhD gives you somewhat more breathing space, a bigger outcome, and more high-paying opportunities. See, typically, right, so I'm talking about an average student who enters. It takes about 12 to 18 months for you to come up to pace with the field and start contributing independently. So all our faculty spoke about so many different things of so many different publications. Right? So on day one, we don't expect you to know all of that. It will take some time for you to ramp up. It's fast. Some students are very fast. Maybe in 6 months, you reach there. Some students take a little bit more time, 12 months. But before 18 months, most of you come up to pace with the field and start contributing. In the next 18 to 24 months, right, so you can publish 3 or 6 papers. If you publish 3, you can get an MTech research. If you publish 6, you get a PhD. It will take you hardly 12 more months, right? So 6 to 12 more months to complete a PhD than an MTech research. So in my view, right, so you get bang for the buck if you take a PhD, right? So, and many of our students graduate in the time frame of 3 to 5 years, and most of that time is actually spent in self-improvement, right? So PhD is a journey of self-discovery, right? So you are the lab that you are building, right? So and then you can reach some place comfortable. In fact, if you take a BTech and join, at the end, IAC gives you 2 degrees, right? So you'll get an MTech research as well as PhD in 3.5, 4 years time, right? So when you graduate, see, totally depends on the speed at which you work, right? So if you work 8 hours a day, 7 days a week, you show up, you concentrate, you're not distracted, it is possible. Right? So that's what I'm saying, right? And the industry today requires such people. I will tell you a reality of today. The job market is highly competitive today, right? So the number of papers that you have in these A-star conferences or top journals like Nature, etc., it is now the joint entrance exam of the job market. High paying industry jobs actually shortlist on the basis of the publication in these venues. So if you take a PhD, you actually increase your chances to compete and win in this race, right? So it is very competitive, right? So today, actually, with the advent of generative AI technologies, like what is the difference between somebody who is learning on their own and doing things and somebody who is doing a degree in a top institute? Most of the time it comes into showing that you are capable, right? So this degree, this stamp will tell the world outside that you are actually capable of solving any problem that is thrown at you, and that is the value of doing a PhD, right? So the entry process in research, MTech research and PhD are same, and it is different from MTech coursework. MTech coursework is a gate-based admission where you actually do a lot of courses and a dissertation project. It's a 2 year fixed duration course, and you can sit for placement. So that is usually the kind of jobs that you get with a master's, the role profile, right, is very different from the kind of roles that you get after a PhD or an MTech research, right? So PhD, like hardly like 12 months difference between MTech research and PhD. So you should. It's like, do you want a medium size popcorn or you want a large size popcorn when you go to PVR, right, to watch Durandar 2, right? So do you choose a medium or large? Like it's like the price difference is too small, right? So might as well choose large. That's the idea of selecting a PhD. Okay. Now the salaries, right, of people who graduate with PhD is uncomparable with MTech, right? So it's like leagues apart, right? So that is definitely there. Actually, we don't publicize that statistics because the numbers are insane. Most of our PhD students pay surcharge on income tax. So if you can Google what surcharge on income tax means, you will get an idea about the range of salaries that we are talking about, right? So, but most of our MTech students don't pay surcharge on income tax. So I'll leave it at that, right? So without saying much more. Okay. Will you get a recording of this video? Definitely. I will put it on YouTube and share it with you. I have an MTech degree in CSE. I wanted to ask if I select one of those labs accepting from CSE, I will only attempt part A. Yes, you will be here. So the question is, right? So if you have CSE, will you be selected by labs that are accepting all backgrounds? Definitely, right? So all backgrounds include computer science and engineering also. Right, so thank you to professors for explaining. Okay, could you please provide a list of labs accepting MTech research this admission cycle? So all these labs will accept MTech research or PhD, but they will prefer PhD, right? So in most cases. My BTech is in IT. Am I eligible for NLP? Yes. Are MCA candidates eligible for 5 labs? So can someone of you answer? Maybe Professor Venkatesh or Anirban. Are MCA candidates eligible for your labs? Yogesh?
Yeah. So MCA is seen as a circuit branch, so MCA will be eligible.
Okay. Yeah, MCA will be eligible. Okay. Do we have to decide in the form itself whether we take a PhD or MTech? You can select both if you are interested in both, right? So there's an option called both. You can select both. I have done my BS in data science. Am I eligible for joining the DREAM? So that is the online BS program, is it, from IIT Madras? Yeah, I think you should be. Suppose I am interested in joining the matrix lab, but I have no background in engineering physics. Should I prepare these separately? You can focus on the subjects that you know and confident of answering. Yeah, that's it. You can focus on that. What would you prefer in take PhD or MTech? Most of the faculty will prefer PhD students. Yeah. Is having a prior published paper necessary for admission? No, it is not necessary. What does the panel expect from MTech research candidate compared to PhD? The expectation is the same. MTech research and PhD candidate, our expectation is the same. Do we share GPU with other department? Can we take GPU from KIAC? So almost all labs have their own GPUs. You can also use all shared facilities, all paid facilities. You can also use GPU from India AI. That is possible. So GPU, we don't have any dearth of GPUs in the department, right? So I have written test and interview for IIT Bombay on 11th and 12th. So please send an email. I'm interested in multimodal AI with target of working in a big tech company. I can see all three labs offer multimodal AI. Based on my target of working in these companies, outer which lab might be better fit. You don't see. That's what I told you, right? Don't select a lab based on your perception today of what jobs you will get 3 years later. Look at the topics, and if you are comfortable with those topics, select those labs. That is the right approach. I am working in Tokyo, Japan, and it's not possible for me to come to India. We are very sorry. You have to attend in person. Okay. Does CDS or PhD programs offered together with a different university? Why do you want to do such things? CDS is the one of the top universities in the world, right? So our degree is no less than any top degree in any university in the world. So you must, you must be proud that you can spend your 3 or 4 years staying in beautiful IIC campus in Bangalore and doing your PhD. Okay. I want to join Mars Lab, but I am from mathematics and computing branch. You have Chan. You can select. Yeah. Okay, I think I did all the questions. Here. Does IAC provide hostel accommodation for interview candidates? I don't think so. Supposedly, if we manage to do some work during our PhD, which can be a startup, we absolutely welcome, right? So if you think you can do startup from your PhD work, our faculty will be the first to tell you to incorporate and go ahead. In fact, IISc has a Foundation for Science, FSID, which has a program for student entrepreneurship, incorporation. In fact, I already told you, right? There are 2 faculty in the department who have startup. One is the BCL, Devnath Pal, as one startup. Another faculty who's actually not taking students this cycle. They have a startup which was selected in the India AI mission, right? So we are very much interested in entrepreneurship. We very much encourage entrepreneurship also, right? So you can definitely be able to do that. Okay. New post. I have bachelor's from non-circuit lab, mechanical engineering. I am interested in Dream Lab. Yogesh, this a candidate from mechanical engineering who is interested in Dream Lab. Like, what is your advice?
So if something sort of that stands out in their prior training, we may consider it, but let them include it. So on the day of the interview, if they get selected for phase 2, we can take a look at it and then decide.
Exactly. Yeah. In BTechs in IITs, if time permits, students get to work outside department and projects we are interested in. Is something like that possible or allowed in MTech research? See, let me be very frank with you. To do quality research in one topic, you need about 2000 hours of work, give or take. 2000 hours of work, give or take. So what is 2000 hours of work? It is 8 hours per day, 5 days, that is 1 week, 50 weeks in a year. If you work more, right? So you work 12 hours, 14 hours, and I'm not talking about just sitting in front of the computer looking at X and YouTube and like chatting with the people on WhatsApp, right? I'm talking about focused work, right? So you sit and work. If you can do that and still manage to do something outside, why not go for it, right? So, but most human beings, right? So that we know of, have to sleep, have to eat food, have to wash their clothes, right? So have to go for a haircut, how to watch a movie, right? So like if Durandar 3 releases, we have to go first day first show, right? Like so, if that is the case, then maybe you won't get time to do something outside, some project outside in the MTech research, right? So you must select, right? So some lab or topic that you think you are really interested in and work on that. So see, postgraduate degree is very different from an undergraduate degree. Postgraduate degree is where you focus, you specialize, you gain skills that only you have. See, at the end of PhD, my advisor used to tell me, right, so that at the end of PhD, you are the world's top expert in that topic, right? So more than your advisor even, right? So that is the level of expertise that you must develop. So that effort you have to put in. And why should you put in that effort? Because industry outside, after job, after course, right? So jobs that you get, they are all interested in top performing candidates who can solve any problem, right? So in that case, this is the best training that you can get. And you can make mistakes, right, while doing MTech research or PhD, which you may not be able to do in an industry job. Like if you make a mistake, you're put in a PIP program and you're fired in the next quarter. In an MTech research or a PhD program, right? So you can make mistake, you can recoup in 2 months, right? So 3 months. So there is some amount of resilience because you're still a student, right? So you're ultimately you're responsible for your thesis, but it's not like somebody will fire you, right? So for some small mistake along the way. Is it possible to join as an MTech research and can convert to PhD? Yeah, it is possible, right? Are MSc mathematics students eligible for DREAM, Mars, NLP, VAL, VCL? See, eligibility wise, maybe not. That's why Professor Yogesh was saying that if you have some background that will allow you to answer those questions, you can. So in part B of the programming, please do answer the DSA questions, right? So if you get that right and get selected, you can definitely interview with them, right? Integrated PhD or PhD. I mean, if you only have a BTech, you will get both PhD and MTech research at the end of 3-4 years, right? So you can join for direct PhD. Yeah. Is BTech in AI data science allowed? Yes, it is allowed in all labs. If I select MTech research in the form, will I be later allowed to update it to PhD before joining? During your interview, you can tell the panel what you are interested in, and there will be a discussion, and at that time you can decide. But if you are interested in both, select both. How many students are selected for MTech research? What will you know by? What will you do by knowing that number? Will people having a minor in data science stream be selected for CV and DL labs? See, it's not like, if you have a minor, you should know that subject, right? So the issue really comes here in, do you have sufficient knowledge in data structures, algorithms, and do you have the requisite background to start contributing to those labs? I mean, see, as of today, India produces 12 lakh computer science graduates, right? So it's only 4 lakh other subjects. So there is a lot of supply in computer science, data science, AI. So it's less supply in, let's say, mechanical engineering and all the other branches. So, I mean, do you want to be a small fish in a big pond, or do you want to be a big fish in a small pond? This is something that you have to think about, right? Okay, I think that I got. Now let me come to the chat. So if I have allowed you to come on a different date for the interview, on the form you select the new date. Why are some labs putting CS background? Constraint. No, it's not constraint. It's what I just explained to you, right? Like it's all about whether you would be able to contribute, right? So start contributing in 12 months. Like it's not anybody's, it's not in anybody's interest. If you have to start over and study all first in, first out, linked list, blah, 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 right? Or depth first search, breadth first search, all these things. If you have to start studying from first up, it will take you 3 years to reach up to pace and then start contributing. So we are doing competitive research, right? So since we are doing competitive research, there's a time pressure, especially in the fields of AI, HPC systems, etc. Right? So there's just a lot of time pressure. So you would want to start hitting the ground running. So in that sense, it kind of makes sense, right? So that you have the necessary background to do that. Is it possible to work with multiple labs or restricted to one? That choice of word is not correct. It's not about restriction. It's about choice. Right? So you have selected to work in one lab where you want to specialize in. So I wouldn't say restricted, but you will be selected to work in one lab and you are expected to work in that lab. And as I said, the amount of time that it takes to contribute to any research is immense, that you would have time only to spend in that one lab. Okay. Is there any chance to change the date and timing due to clash with interview with another institute? Please send an email with all the details. We will consider it. Same day slot in AI department research in the afternoon. Will it be a problem? No, like 2 slots, right? So it should be fine. My call letter mentioned 2 p.m. for CDS, but in presentation, please come at 12:30. Right. So if your call letter mentions 2 p.m., that is afternoon session, please come at 12:30 or 1. Between 12:30 to 1, please come. Okay. I am trained as a physician and currently working at Google as a product manager. I am really unsure about the test and interviews. Would be great if I could get any advice. So I just explained what the test will contain, what phase 1 will be, what phase 2 will be. The brochure contains all details about what phase 1 and phase 2 of the interview will be. Please go through that. Okay. What is the seat matrix for MTech research and PhD? What will you do by knowing that information? I have a BTech in smart manufacturing interdisciplinary branch. Can I be eligible for the ECS labs? If you know data structures, algorithms, and those advanced interview topics, and you are confident that you know that more than people who have spent 4 years, 5 years studying those subjects, be my guest, please. I have done my MSc in big data biology. Am I eligible for like if you got selected, if you got a call letter, that means you are eligible to appear for the research, right? So interviews, so please come. Am I holding masters in mathematics? I want to contribute to these things and I'm willing to put all the effort, but I might not have the straight away knowledge. So please develop that knowledge, right? Study for the next 1 year and apply next year. Right? Make sense? IISc, does it provide for interview candidates accommodation? And I actually am not sure, but I don't think they do. Like, does anybody else know? Funny or Yogesh?
No, they don't have any accommodation. This is
okay. Like for all candidates, right?
Yeah. And one more question which is coming very frequently is what is the weightage given? They're getting confused, like what happens in MTech. That may also be clarified. Yeah.
Okay. Yeah. Yes. Thank you. So in the MTech course, it's like 70% gate and 30% of that aptitude test. Here it is not like that, right? So it is completely based on the interview, the final oral interview. That is what will decide your selection or not selection, right? You have a BTech in mechatronics. Can I pursue Dream Labs again? Right. So all these questions, my final answer. If you have the necessary background to answer those interview questions, hit the ground running. Sure. If you do not have, please make a choice on the basis of that. See, there's a big difference between your aptitude and your ambition. So you must make a choice that is aligned with your aptitude. Yeah. Will the interview focus mostly on subject knowledge or MTech thesis project experience? It will be on subject knowledge. Yeah. How much journal and conference paper are required in PhD? See, there is no requirement, but see, as I told you, your publication is your currency in the job market. Okay. Just like the joint entrance exam today, the A-star circuit and the top journals are the competitive field for your next opportunity. Whether it be grants, whether it be promotions, whether it be jobs, whether it be startups, whatever it is, right? So you have to now show the world that you are capable. Now, what is a way for a research student to show the world that you are capable? It is through these publications and the publications in top venues. Because today there are a lot of predatory journals and everything. So publication by itself is not that valuable. It's in top places, right? So where selection bar is very high, that shows that you are capable. You just think of it like the JEE, right? Like you might be super brilliant, but if you are not in the top ranks of the joint entrance exam, you do not get a seat in IIT Bombay, right? So similarly, like or IAC. So it's the same game, right? So if you have a clash with another institute, please send me an email with all the details of what the exact clash is, and we will consider it. But you have to come in person, right? So there is no online option available. Okay. So I'm not answering any more those circuit, non-circuit questions. Okay. So any clash, you with proof that there is a clash, you send me an email. How are interview topics different from aptitude test, linear algebra, probability, and statistics? The type of questions will be similar. The aptitude test. Is there a minimum requirement of 2.5 years of MTech research? Not minimum requirement, right? So, but typically people take, right? So you have to spend the effort in studying, right? So and then contributing. I mean, it's typically what we see. There's no minimum requirement. Sir, I have a given gate in DA, but my BTech is in civil. I am interested in lab. Yeah, you can apply, no problem. So which date should you appear for the written test? It is the date that is written in the call letter. What date should you fill in the Google form? It is the date that is written in the call letter. That is the date that you should fill in the Google form, not any other date, right? The dates at IAC are clashing with IITs. IIT Bombay, we are aware. So if that is the case, you please send me an email and we'll make, you can appear on a different date. Is some other IIT, we are not aware. So you please send an email.
Sir, IIT Delhi.
Yeah, so please send an email with the information. I am from bioinformatics background and more interested in genomics domain, but I don't have maths background. So please prepare maths, right? So if you think that it will be tough to qualify, please prepare. Right? So and be at the top of the game in math and then come. My interview dates are colliding with IIT Madras. So IIT Bombay and Madras also have the same date. Is it like please send an email? We will. Can we play GTA 6 in the labs? I mean, I guess it depends on the labs. If Can I come in? Are there any labs which conduct research in the area exploring the role of deep learning in computational finance and related area? Not in CDS right now. How do I know that I am a fit for research? How do I find about it? So I told you, right? I have done 1.5 hour session on if research is a right career for you on my YouTube channel. So you can take a look at that. It should have answers to your question to figure out like what is research? Like, does it make sense for you to do research, etc. So you can check that out. For a new student joining a lab, how is the first research problem usually identified? So it is typically a continuation of an existing project. Students also have the freedom to pursue different. So all these things, right? So when you come for the interview, you can discuss with that faculty, right? So you can discuss with the students also to figure that out. So it depends on lab to lab, right? So in most labs, you do have some amount of freedom and some amount of direction. So it's like kind of a combination. During the application form fill up for the research program in the admission portal, I selected only MTech research. Is it okay if I select PhD now? Actually, I think you can update your application portal also, right? So to select
That's fine,
PhD.
right? So Deepak, that should be fine.
That's fine. Yes.
It doesn't matter. Yeah. So research program is logically one program, so it shouldn't matter.
That's fine. Yeah. Okay. How is MTech research different from MTech 2 years? Okay. MTech research is a research-based, a thesis-based program. Right. So you do 12 credits of course, and you work on your research from day one. You will be in the lab that you are assigned to, and you work on your research. Typically, in the field of AI, you will publish 2 to 3 papers in an MTech research thesis, right? So that is MTech research. MTech course, on the other hand, is a course-heavy program. So you do close to 36 or so credits of course and about 28 credits of project work, leading to 64 credits that you complete. Now 36 credits of course is like a lot of courses, right? So it's like at least 12 to 13 courses you do over the period of 1.5 to 2 years. And the project work there is a dissertation project, which is time bound, right? So you do it in a specific manner. So MTech course is different, MTech research is different. It's a good question because I think I have seen a lot of misinformation spread on Reddit and Quora and YouTube, especially from Gate coaching institutes, that MTech research is kind of like a backdoor entry to MTech course placement. It is not. MTech research is a research program. It's a respected program that stands on its own. It's similar to PhD. So, but you get a master's, right? So, yeah. Is preference given to professionals with industry experience over freshly? There is nothing like that, right? So we give preference to people with raw intellect power. So for Dream Lab, what are the ways in which students can demonstrate skills in system software? Is it through prior project experience, Yogesh?
Prior projects are fine, but projects can seem very superficial, right? So what we require is fundamentals, right? You actually understand what went on in the project, right? So that's really what you'll be asked about. Let's say if you choose operating systems, right? Do you truly understand operating systems? Do you understand the concepts? Do you understand synchronization primitives? Do you understand how the right? So because at the end of the day, research is about building on top of foundations, right? The foundations are weak. You could have done a sort of full project, but the project is very superficial. That's not going to really count for much.
Okay, thank you. If a candidate has a 2-year drop after BTech, does this lower the chance of selection? I don't think there is a correlation between the number of years after your BTech and your chance of selection. There is definitely a correlation between your knowledge, your ability to handle pressure and get clues and solve problems that are thrown at you, and your selection. That is correlated, not the years and. For the advanced topics in the interview, do we have to prepare at an advanced level in that topic, or like fundamentals will be good? So do as much as you can, right? So if you have time only to prepare the fundamentals on that topic, do prepare and then inform the committee when you come to the interview that this is the level that I have prepared for. So that should be okay. I am from a pharmacy background. I am interested in automation in pharmaceutical fields, especially in drug delivery, pharma. Since CDS is more AI data science, actually, I don't know how to answer your question. So from your pharma background, if any medical Biomedia or MIG lab is good for you, you can maybe approach them, you can write to them and see. But directly, maybe BCL lab also, right? So biomolecular computation lab, so you can try there. Will the stipend of MTech research and PhD be same? No, they are not the same. MTech research stipend is at the master's level, PhD stipend is at the PhD level. So they are different. I actually don't remember the numbers. If anybody else knows the numbers, you can say, or you can like maybe just Google, right? So like, what is the master's stipend?
3x difference, 3 times difference.
Three times, okay. Yeah, PhD stipend is like 3 times it seems from the. I have an interview from 2 p.m. at CSI department. It's okay. Like if it's getting late, you just inform the panel that you have to go somewhere else, and they will call you. What will be the complexity of the coding question in exam? So the DSA questions will be fairly DSA complicated, right? So it will be. Is NLP lab working on foundational architectures? I mean, you can write an email to the faculty and ask, right, what are the kind of problems that they are working on. That will be the best way. But if you are interested in foundational model development, my lab is working on foundational model development, scientific machine learning, foundational model development, multimodal AI. Is it compulsory to attempt both the sections in the written test? Yes, it is. But in part B, you can attempt as many questions as you can. You attempt the questions that you are most comfortable with. We think that with the time available, you can attempt 2 questions correctly. So, what is the evaluation criteria for the written test? It's like mark, right? So it will be an MCQ, and so if it's correct or wrong, so some marks will be there based on that. How long does the interview typically last? It depends on you, right? If you answer questions very quickly on the point, it can get over fast. If you need a lot of help in getting set up, understanding the question and then keeping going, it might take a little bit more. But if your question is about when you can book a return ticket, then if you are in the morning session, please allow time until 4 p.m. If you are in the afternoon session, please allow time until 9 p.m. Right? So to and book only after that. Is there any specific dress code? Okay, thanks for the question. Wear something that you are comfortable. Right? It's summer season. Like, don't wear a suit, boot, and all and come. It is very hot, right? So, like, wear something that you are comfortable. But don't come wearing a earphone hanging around your neck, right? So, and maybe don't come in tone shorts and night dress. Like, be respectful of yourself and others, and choose something appropriate. Okay. Like, don't wear uncomfortable clothes. Yeah. Yes.
Deepak, can I just quickly clarify on the last question? So for people who are coming in for the second half, if it is possible, try to have a return booking the next day, because some panels run very late. 9 p.m. might be too soon. And yeah, the airport time also, like you need to give some leeway, and yeah. So if possible, like next day would be better.
Yeah, I already told them to do.
Okay, thanks.
So Deepak, if I may use this interruption to also add something else, right? On the interview part, right? So one way to think about it is that we are trying to evaluate how you think, right? Because that's really what you'll be doing for your entire research. You'll actually be having conversations with your advisor, with the other lab students, and so on. And you want to make sure that you can think quickly with the ingredients that you already have, right? And typically, the best ingredients are the fundamentals being strong, right? And we want to see the process that you take in solving a problem, right? It might be a problem that you've never seen in your life, or it could be a textbook problem. But even a textbook problem, even the answer is not what we're for, right? You truly understand the answer. Could you go to first principles and derive those answers, right? So that's really what we look for, your thinking process, not just the right answer.
Absolutely. So just to repeat, if the audio was not clear, we are interested in the way that you think. right? So your process of approaching a problem and logically walking through the required steps is what is necessary. It is not there might not be one right answer for a problem, and it's not like your BTech course exams, right? So where there's one answer, everything else is wrong. Like it's not like that, right? So your reasoning tokens, if I may use the word, right? So have to be in a particular order that makes sense. Right? So that's okay. So that is good. I think I did everything. Some question about placement. Okay. If we have CDS at 2 p.m., recommended to reach by 12:31 and AI at 9 a.m., if the interview goes on longer than expected, can the CDS exam be postponed on that day itself? No. You adjust your time and come. You can inform the AI panel that you have another exam at 2 o'clock, and so you please come there. I don't have a call letter for the interview yet, but based on the written exam for MS at IITM, it is mentioned that I might get 10 11. So if you get that, with that call letter, you send me an email and we will see what can be done. I understand that the final offer is based on F2F face-to-face interview, but for selection to the interview is written exam the only criteria. Gate score will be considered. Gate score will not be considered. Okay. Will the written test have weightage in the final selection? No, it will be only on the basis of the final interview. Can you please share the point of contact for admissions to AI department? Danish, do you have an answer to that question?
Yeah, I can, like the point of contact is Rajiv's, but I can give you the contact email address for that. I will type it on the chat while you can take up follow-up questions.
There was some question on placement that I missed in between. Not able to find it again. Okay, I'm not able to find that question again. So if some question remain unanswered, you can send an email and we will try to answer that question. So I think we are at 8 o'clock. We have spent 2 hours describing the department courses, and this slide shows the 14 labs that are accepting students. So once again, to wrap it up, you please fill the candidate information form, the link that I have emailed you, and select the 3 labs that is your preference. How to select the lab, the algorithm for that I already told you, right? So spend time looking through what each lab does, identifying what is what you like, what you dislike, then make an informed choice, right? So it is very important that your aptitude meets your ambition. That match you have to choose and put in the application form, I mean candidate information form, and we wish you all the best. We do hope that all of you succeed in whatever you choose to do, and we do hope that you give us the opportunity to be the host for you for the next 3 to 4 years when you do amazing research, taking India to the next level in these leading cutting edge areas. With that, I close this session. I will post the video of this online and share that with you all. Best wishes.
A big thank you to Deepak for this marathon session. Thanks a lot, Deepak. Really appreciate it.
Yeah, thank you. Bye.